I'm Robert Burke, and I'm here to get day 3 going with the state of the Go SDK. I work at I work at Google as part of the Dataflow team, leading a project to use the Apache Beam Go SDK to process data internally at Google. You might also recognize me as the one in the Beam Go Slack or the dev list answering questions in terms of the Go SDK. As you've probably heard during this summit, there are currently SDKs in 3 languages: Java, Python, and Go, with Go being the least mature of them. As such, it gets a whole talk to itself to cover its current status. First, a little background on the Go SDK. The Go SDK was first merged into the repo in late 2017. It's also the first purely portable SDK. There's never been a non-portable version of the SDK, which means unlike Java and Python, the Go SDK can only run on portable runners. As such, it's been growing up along with the development of the Beam Portability project. Without the Beam Portability project, there would be no Go SDK. This is partly why, after nearly 4 years, the SDK is still considered experimental. But what else makes the Go SDK different from the others, though? For one, the Go SDK is written, unsurprisingly, in the Go programming language. If you haven't heard, the Go programming language is garbage collected, has powerful runtime reflection, easy concurrency, you can use multiple return values, it's statically typed, and the statically linked binaries are compiled very quickly. It also has an adorable Gopher mascot. But for all that, it does pose some challenges. Go doesn't have some of the features that Java and Python do. There's nothing like annotations or decorators. There's no native serialization like Python's pickling. You can't overload functions or methods, so we can't apply transforms to p collection ad nauseum. But nor can you inherit from some base class. And of course, everyone's favorite, there are no generics. At least not yet. They're coming in late 2021. This is fine. This is totally okay. Despite all of this, we wrote a Beam SDK with Go. The original design RFC linked right here. I'll give you a brief moment to copy that down if you like. It describes how the SDK has been put together, so I won't cover it in this talk. We only have 20 minutes after all. So at this point, you might be asking, what works in the Go SDK? Well, in this case, all the basics you need to transform data in batch. We have global windows, they're propagated throughout. Pardos are able to execute anything from simple functions to configurable structural do funds with 0 or more emitters. You can group 1 or more sets of KVP collections with co-group by keys. You can write combiners, which support the combiner lifting optimization, assuming the runner supports it. Also flattens, p-collection partitioning, user metrics, side inputs, and a multitude of standard Beam coders. And if the standard coders don't do it for you, you can register your own. Another thing that works is performance. As I said, we're using this internally to Google, and at Google scales, even a small performance improvement has big impact. I mentioned reflection earlier, and the Go SDK uses it throughout. Not only to type check your pipeline at construction time, but to synthesize new values and call your do funds at execution time. However, while Go's reflection is pretty quick at those first 2, it's a little bit slower on that last one. So I wrote something that helps with that. I called it StarkGen, and it's been in the Beam repo for the last year. You tell it about your do funds, and it will use static analysis and a few templates to generate type assertion wrappers to execute your code as much as 1,200% faster, which means your pipeline takes less time and is way more efficient on CPU and RAM. So all this lays a firm foundation for data processing with the Go SDK, once you can get your data into it. But this is the state of the Go SDK. So what is new in the last year? So this is my favorite part. I get to call out a few people who've been doing work on the Go SDK and say thanks. Not everything I'm mentioning is 100% complete, so please file a JIRA if you find something interesting when you're trying these out yourself. First up is katas. If you didn't already know, Code katas are interactive coding exercises that can help you learn Apache Beam concepts and the programming model hands-on, using JetBrains for education. An enthusiastic new contributor, Damon Douglas, asked me a few months ago if I thought it was a good idea, and I agreed wholeheartedly. He covers all the basics I mentioned and more. You can find them in the GitHub repo under Learning Katas Go. Next, so thank you very much, Damon. Next is Loopback Mode. In a nutshell, it tells any compatible runner to talk to a server of our choice in order to spin up workers. So while these workers could be distributed themselves or separate processes, Loopback Mode spins up the workers as threads in the pipeline's main process. This makes it much easier to develop a pipeline or work on the SDK itself, since you can just console print normally or connect a debugger to the main process. This is a protocol I believe Robert Bradshaw came up with and implemented initially for Python on the portable Python runner. I believe it also works in Java and against both Flink and Spark. I did the Go SDK work, but thank you, Robert, for such a clean and easy protocol. We just add in environment type loopback and away you go. The next two things, though, are really exciting and are still having their final details worked out. So please pardon their dust. Their contributors worked very hard on them and deserve your attention, as both features are critical for the Go SDK moving forward, since they unlock the ability for Go SDK pipelines to scale. Over the last 3 months, I was privileged to work with an intern called Kevin Puthasari, whom I was able to assign the task of getting cross-language transforms working in Go. As Ken mentioned in his opening keynote, twice actually, cross-language transforms are a key feature of Beam, and letting us use high-quality transforms in our pipeline, no matter what language they were written in. Doing this allows the Go SDK to share the benefits in time that has already been spent on Java and Python. Kevin finished their internship last week, but before they did, we were able to merge in the verification examples, validating that we can insert transforms from both Java and Python into a Go SDK job. That's right. We can finally see the apex of Beam portability. We can write a Go pipeline with Java transforms executing on a Python runner. That's 3 times the Beam. The code needs a little bit of cleanup, and the API needs adjusting, but that we got there at all is a testament to Kevin's tremendous work in the last 3 months on a remote internship during a pandemic. Thank you, Kevin. Wow. On a similar note, we also believe you shouldn't have to rely on Java and Python transforms for Go pipelines to scale. For one reason or another, pipeline authors like yourselves might need to write your own scalable transforms. So for the past year, Daniel Oliveira has been working on adding splittable do funds to the Go SDK. As the name suggests, this critical feature lets your do funds split at a sub-element level and be able to subdivide work for the runner to distribute to other workers, either via initial splitting or dynamically at execution time, such as with Dataflow's liquid sharding. You can learn more at Daniel's talk on Friday, where he's going to give a tutorial at 5 o'clock UTC, and I unfortunately haven't converted that to Pacific time yet. But that's not everything that's changed with the SDK in this last year, though. Late last summer, state-backed iterables were added. This allows for hotkeys with large quantities of data to incrementally page the data associated with a key over the state channel rather than the data channel. This yields a more efficient use of memory, so you don't have to have the entire key and its iterable values to be in memory all at once. Not unless you absolutely need it. This gives the runner options and choice to run more efficiently. Also, data channel splits were added, letting the runner tell the SDK to finish a bundle early after processing a specific element, again allowing the runner to distribute work better. A reshuffle transform was added to the SDK, and this lets users manually insert fusion breaks into their pipelines, which lets the runner, again, scale things up and down as necessary if it supports that. And on top of that, internal use of the SDK within Google has allowed construction and execution time bugs to be found and fixed, improving the overall stability of the SDK. So, what's next for the Go SDK? Since these timelines were long in prepping this summit, I was hoping to be able to tell you that the SDK could be no longer called experimental. Unfortunately, due to the advent of a worldwide pandemic, we haven't quite got there yet. But we're close. For the longest time, the bar for exiting experimental was resolving the scalability question. Once we had splittable do funds, we could exit experimental. With cross-language transforms, we could exit experimental. But while we were developing these solutions, I learned that we needed one other thing: data stability. To me at least, experimental as a state for the project is permission to make breaking changes to the SDK so it can work better when it actually exits experimental. Fortunately, we've been working on the effort for improving data stability. We call that effort Beam schemas. Schemas are a way of defining coders with compatible encoding strategies for a given type. Critically, this lets different SDKs convert data to their native formats efficiently, and also allows runners to introspect the structure of that data as well. However, to get there, we need to make one last breaking change to the Go SDK. Right now, the Go SDK uses JSON encoding by default, which, if you know anything about JSON, is a bit inefficient since every element contains the structure of the data. True is 4 bytes, false is 5 bytes, and those are just booleans. The number 1 million is 7 bytes, and that's not even counting their associated field names. Schema coding, on the other hand, doesn't repeat this structure every time, and encodes data compactly, granting significant performance improvements over JSON. If we make schema the default encoding, everyone can reap the benefits. After schema support is added, we need to join the Go ecosystem properly by making the Go SDK a Go module, which is the Go language ecosystem's unit of versioning. This will require a slight import path change for users, unfortunately, because right now, notionally, the Go SDK is V1-ish, but for practical purposes of the ecosystem, it actually matches the version tag on the Git repo, which is 2.23, if I recall correctly right now. Might be 24. Besides the point. So with that, though, that'll be a nice hard signal that the SDK has exited experimental. Soon. We're getting there. But at that point, we're far from done. There's a wealth of improvements we can make to the SDK, from missing implementations of Beam components like map side inputs, windowing, state timers and triggers, checkpointing, to writing some Go IOs using splittable do funds, and we need to provide Go wrappers for Java and Python transforms, but also we should pay back the favor with a Go expansion service so those languages can use Go transforms. We need to shore up our testing of all of this and more, and finally next year, possibly reap the benefits of generics landing in Go, and maybe I'll get to delete my code generator when that happens. After that, who knows? It's your project too. I'm sure you have some ideas. That's all I've got right now, so I'm hoping y'all have some questions to fill out the last 5 minutes. But before I hand things back to Matthias, I'd like to thank you for watching and just call out some upcoming talks on the related topics. In about 2 hours, there is Go SDK office hours in the SDK space in the GatherTown platform. So I will see you there if you have any additional questions. But for more on schemas, the final talk for today is simpler Python pipelines with schemas, SQL, and data frames. If you want to know more about cross-language transforms, on Friday, Alexi is giving a Python 3 transforms in Java talk. And also on Friday, Daniel is giving a tutorial on writing splittable do funds in Go. Thanks. I've been Robert Burke.
Thank you very much for this exciting update, Robert. I am personally looking forward for the Go SDK to come out of experimental.
Mm-hmm.
And I actually know some people that are or might be quite excited to contribute. So if that's all right, I will direct them your way.
Oh, absolutely. I was like, I pay attention to anything that mentions Go and a lot of things that don't mention Go, so I can mention Go.
Okay. Perfect.
Especially with cross-language transforms and splittable do funds, converting the existing IOs, such as the Go SD currently has them, into splittable do funds is very valuable. As is finishing off some of the cross-language work, because then we can start using, I don't know, Kafka as part of the various transforms, and also more easily test a lot of the streaming stuff in the Go SDK. There's a
Fingers
lot of
crossed.
work to do, as I already pointed out. I mean, look at this. We've got stuff for at least another year or two. This time, if more people help me.
Excellent. I know where to find you. There are a few questions from the audience if
Oh,
you're happy to go ahead and answer.
yeah, please.
Cool. The first one is: does StarCGen only work with the Go SDK or StarkGen? I'm not sure.
Yeah, StarkGen. It only works with the Go SDK. It is specifically a Go SDK construct. So in Java, you can use the just-in-time compiler to JIT everything in and improve bytecode as the JVM is running. Go doesn't have a JVM, and it doesn't run on the JVM, so it can't use that kind of just-in-time compile magic to generate this bytecode. Python has PyC, which is a little bit closer to what the Go SDK needs to do. So instead, the Go ecosystem has a specific set of tooling to trigger code to generate, and the StarkGen tool can be used as part of that to generate things for your do funds. It's unfortunately a manual process, so you need to annotate your code and then, well, not annotate because Go doesn't have annotations. You need to comment your code and then have the tool run, but it's relatively painless, and it inserts a new file into your package with the various bits of code generation. If you look for any of the shim.go files in the Beam repo, you can see examples of what code gets generated.
Okay, really cool. And, I think that covers that question. And we have another one actually, and I think you kind of covered it already, but I'm gonna go ahead and ask it anyway. What about streaming support in the Go SDK?
So streaming support's always kind of an entertaining thing. So technically, the main thing that we need is, like, I don't know if the slides are up at this point, but like I've moved back. One of the key things in order to support streaming is being able to subdivide work a little bit more easily, because by default, if for any native do funds right now, you only end up with one worker, and that provides a severe bottleneck in actually doing anything. So you want to be able to split up that work. So that is helped by actually having splittable do funds. However, with any specific streaming transform, you actually also want to be able to have the streaming transform say, "I'm done for now. Get back to me later." And that support requires checkpointing. So the combination of splittable do funds and checkpointing helps solves this. On the other hand, cross-language transforms provide the other avenue, because checkpointing and such are already implemented in Java and Python. So if you wrap the appropriate source transform, like, say, a Kafka transform, then it'll probably work, because the cross-language infrastructure will take care of the rest of that. So the only other thing is that the windowing logic, while it's been unit tested to a certain amount, it hasn't been rigorously production tested. So as with anything on the streaming side, it's used at your own risk, and I definitely want to hear the results.
Awesome, cool. I know you're gonna stick around for a bit more in Slack and in the office hours later today.
Yeah,
So yeah, go find Robert there, and you can definitely have a chat. Thank you very much, everyone.
thanks.
Oh, there's a final question that just arrived.
Mhm.
Sorry, are you happy to take another one,
Oh,
Robert?
please, yeah.
When will the Go SDK have its own mascot?
Well, I think that's more of like a friendship picture between our wonderful Firefly mascot for Beam and the gopher, the Go Gopher. I mean, really, I just want an adorable Firefly plush so that I can, bolster my existing collection over here.
We should start making family sets of plushies, I guess.
Yeah, honestly, I think it's like if anyone's got artistic skills, do some fan art with like the Go Gopher wearing a beam logo and the beam datum Firefly wearing a gopher.
I do like that a lot. Cool. Awesome. Thank you again, Robert.